Jupiter played a crucial role in developing life on Earth. Thank you, Jupiter. We normally just see the very top layer of atmosphere. There are so many secrets of Jupiter contained below these clouds. So I'm currently analyzing data from the Juno spacecraft.
Juno, the spacecraft, has all these magical instruments to see inside of Jupiter. Jupiter is the most extreme environment NASA's ever visited. To send a spacecraft there is a little bit insane. This is one of the largest spacecraft ever made. We had to, build an armored tank to go there.
Jupiter's radiation environment is the most dangerous environment for a spacecraft to go into. It's a region we were very afraid of because no one had ever been there before.
If that doesn't fire just right, you fly right past Jupiter. That's it. You don't go into orbit, you go around the solar system again. By the time you come back to Jupiter, it's decades later.
Almost there.
It's a very uncomfortable situation.
Welcome to Jupiter.
We just did the hardest thing NASA's ever done.
What we actually found blew our minds. When you first look at Jupiter, what really catches your eye is the Great Red Spot. It's this gigantic storm in the southern hemisphere of Jupiter. It's larger than the Earth. It has been around for over 200 years, and it's absolutely incredible. Then you begin to look further away and you see these belts and zones moving in different directions on the planet, and everywhere you look, you basically see a storm. And what drives these storms? Well, likely Jupiter is collapsing very, very slowly. This is energy left from its formation, and this energy is released, and it's that energy that churns the atmosphere so violently all the time. This is in contrast to Earth, where our weather is governed by the sun. A lot of tourists go to northern Sweden and Scandinavia to see the northern lights of the Earth. If you really want to show and something that's on all the time, you go to Jupiter and see Jupiter's aurora. It's brighter than all the energy that all the power plants on Earth can produce, and is actually fueled by a volcano. So Jupiter has this moon called Io, and that's fiercely volcanic, spewing out material near Jupiter all the time, about a ton a second of material. This material gets trapped by the magnetic field as energy funnels down, impacting the planet, and that's the aurora we see.
What we find is vortices, kind of like hurricanes. They're all packed together, and we've been watching them now for a year, and they haven't all merged into one. They're packed in this pentagonal pattern. There's actually 6 of them if you count the one in the center. And they just sort of sit there. And this is remarkable. This is really the first time that anyone has seen such a geometric pattern of cyclones on any planet or anywhere. I look at an image like that and I say, wow. The idea that nature can make such a geometrical structure is fascinating.
We've known since the Voyager missions that lightning exists in the clouds of Jupiter. What Juno's found is there's a second form of lightning at Jupiter.
This is the signal from the microwave radiometer, and it's measuring the heat of the planet, and every now and then we get a spike. Bam! It became very clear very soon that this was radio signals from the lightning in Jupiter's atmosphere. Maybe 1,000 times brighter than the lightning on Earth.
The presence of lightning at Jupiter hints at vast amount of water, and Juno's actually confirmed that in the lower part of the atmosphere, 1 out of 400 molecules is a water molecule. That's a lot of water. Does that mean that there's life in Jupiter's atmosphere? Well, ultimately, we don't know. We have this notion of what life is based on our experience here on Earth. Can we translate that to Jupiter? Can there be life forms floating about in the atmosphere? We don't really know. Jupiter is so massive, about 300 times more heavy than the Earth. And with all this gravitational power comes huge responsibilities. Jupiter originally flung water into the inner solar system, creating the conditions for life at Earth. So thank you, Jupiter. It also likely altered the orbit of an asteroid that killed the dinosaurs 65 million years ago. Jupiter's presence, gravitational presence, is absolutely everywhere.
This is the outline of Jupiter, and basically what we're seeing there are just the cloud tops. But what we want to know is what's inside Jupiter.
Before Juno, we believed that Jupiter had a really small core onto which gas just stuck by gravitational forces. But what Juno has found is actually that Jupiter has got a really big core.
There's something denser. It's probably like 5–10 Earth masses. It's mostly made of rocks at very high pressures and temperatures. So that shows that Jupiter started its life as a rocky, icy world, and that it captured the gas that was around, the hydrogen and helium. And that formed a giant planet that's Jupiter now.
I first became interested in Jupiter when I was at college in Sweden. There was a telescope on the roof, and one night we got to see Jupiter with our own eyes, and it was absolutely extraordinary. A whole different world that I can see right there in the night sky. What would he think about me today? I think he'd be proud, ecstatic.